All right, today we're going to be taking a look at day 4 review, which is solving literal equations. Okay, so starting off with that, if we're going to be solving literal equations, remember we're going to be solving equations with multiple variables, and we're just solving for one of them. Usually some sort of a formula, like science, area, that type of stuff. And you can use the same process as solving any other equation. We're just going to be adding and subtracting and multiplying, dividing the numbers. So remember, be careful that you don't combine unlike terms. Okay, has to have the same letters with the same exponents. One of the things we're going to pick up is factoring out a GCF. So when you're solving for a literal equation and the letter you're solving for is in two different terms, you're going to have to factor that out. So remember, we're going to look for the largest monomial that is a factor of each. If it's letters, we're looking for the lowest exponent. Okay, numbers, we're looking for the largest thing that the largest factor of all those numbers. So for example, 8 and 16, the biggest is 8. That would be a factor from both. The GCF goes outside, and then remember dividing each of the terms by whatever the GCF is. And the quotient, okay, is what's left in the parentheses. So I should be able to redistribute to get back to the original expression. Okay? So for the first one, I'm solving for C. So I want to get C alone by itself. So one thing I can do is make this a fraction and cross multiply, or I could multiply both sides by D. Either way, I should get R times D is equal to C times S. And then I'm going to get rid of the S here by doing the opposite operation, which is division. And I'm going to get left with the expression R times D over S, which is equal to C. And that is my final answer. Okay, for number 2, I'm solving for y, so I want to get y by itself. So we're going to do like the opposite order of operations here. So normally like addition, subtraction would go last. Here I'm going to do that first. So I want to get rid of the ax first. Okay. So that leaves by is equal to c minus a times x. And then I want to divide by b since I'm multiplying and I want to make this become 1. And I'm going to put a b underneath everything. So y is equal to c minus a times x, all that divided by b. All right. Okay, this is one where I can see I'm solving for r and it's in two different terms. So I'm going to need to factor out that GCF of r here. So s is going to equal r, that's my GCF, and then I'm going to divide r into both of the expressions. So r divided by r is really 1. So if I multiply back through, I should get that r back. Okay, and then capital R times lowercase r here, when I factor out the capital R, I'm going to be left with lowercase r. Now I want big R by itself, so I need to divide by 1 minus r on both sides, and my answer is going to be s over 1 minus r is equal to capital R. All right. Number 4. Okay, so I'm trying to solve for w. So first thing I can do is distribute, or I could divide out the 2, it's up to you. I'm going to get s is equal to 2lw plus 2lh plus 2wh. Now the only thing without a w in here is this middle term. So I'm going to subtract that from both sides first. Then I get s okay, get a little weirder right here, minus 2lw equals, oh sorry, 2lh, not 2lw. All right, is equal to 2lw minus 2wh. And now I'm going to factor that w that's in both of these terms out. Okay, so this side is going to stay the same. And then I bring the w out. All right, I'm basically dividing by w, so the w is going to leave both terms. I can't subtract the 2l and 2h. They're not like terms, so I need to divide by that quantity, 2l minus 2h, and then I get left with my answer, which is s minus 2lh over 2 times l minus 2 times h. And that is equal to w. So that is your answer. Okay, for number 5, same thing. I'm trying to solve for pi. It's in both. So the first step is to factor out the pi. That leaves me with 2r squared plus 2rh. And then I just want to get rid of that. So we're going to divide by that quantity. Notice how I put that all in parentheses when we took the GCF out. So now I can just divide by that amount. So A divided by 2r minus 2rh is equal to pi. All right, the last one I'm solving for f. So if we wanted to, we could divide or distribute here the 5 over 9. The other option is to divide by 5 over 9 or actually multiply by the reciprocal. So it's up to you. If you multiply by the reciprocal, that just becomes 1. So think about it, if I do c and then 9 over 5 times 5 over 9 times f of minus 32, and I also put a 9 over 5 here, so I multiply both sides by 9 over 5. Really, 9 times 5 is 45, and 5 times 9 is 45. This whole thing just becomes 1, okay? So that goes away, essentially. So I get left with 9 over 5c is equal to f minus 32, and then we'll just add 32 both sides. So I get 9 over 5c plus 32 is equal to f. Now the other option would have been to divide both sides by 5 over 9. So what I got, c divided by 5 over 9, right? And then I would eventually add the 32. So this whole thing, c divided by 5/9, and then plus 32 would be another way that I could write that, okay? So if you divided first, that's kind of what it would look like. Don't need that. All right. And then on the page 2 here, so we're doing conversions here. So for simple conversions like centimeters to meters, right, grams to kilograms, we want to remember if our basic unit is meters, okay, or grams, oh, not that. All right, that's kind of hard to see. So it could be meters, it could be grams, all right, that's our basic unit. So if we get smaller, we do centimeters, millimeters, or whether we get bigger, okay, in kilometers or any one of those things, it's going to be what our conversion factor here is. So if I'm going from 5 centimeters into meters, okay, you got to remember that I'm basically increasing by a factor of 2. Centi is 100, right, like a century. So if I'm moving in this direction on my list, going from smaller to bigger, I'm going to multiply or move the decimal place 2 spots, okay? So this is going to turn into 5 centimeters. Sorry, to the left or divide. So we're going to rewind that. Since I'm going from a smaller to a bigger, my amount is going to get smaller. So if this is 5 with a decimal point here, I'm going to move 2 spots to the left. It's going to be 0.05 meters. If I'm going from meters to centimeters, okay, so meters, which is here, to centimeters, and I'm moving instead in this direction, okay, we're going to go to the right or we're going to multiply. So I'm going to basically multiply by 100 or move 2 spots to the right. So this is 320. So in other words, you can think about it as this is 5 divided by 100, and this is 3.2 times 100, okay? So same thing, from kilograms to grams. So if I'm at kilograms and I want to go backwards to grams, okay, I'm getting to a smaller unit, then my number should get bigger, okay? So kilograms is a factor of 1,000, so I'm basically going to multiply this times 1,000, or move it 3 spaces over. Remember, 3 zeros, 3 spaces. There should be 50700 grams, 50,700 grams. All right. And then the other one we have is from grams to kilograms. So remember, that's going to get smaller because I'm increasing. That is going to be divided by 1,000, okay, or 3 spots to the right. So it's 0.03721 kilograms. All right, and this is where it gets a little bit tougher when I'm doing 2 conversions at once. When I'm doing this, what I want to remember is that I'm going to do the units I have times the units I want over what I have. So it's a little tricky to think about, but What I want to do is I want to take what I have already, so this 3 feet per second, okay? And I want to convert this into something. So what I'm going to do is multiply by what's called their scale factor. So if I want to convert miles into inches, what I'm going to actually do is do two things. First, I'm going to take miles and convert it to feet, and then I'm going to take feet and convert that to inches, okay? So the unit conversion is that 1 mile is equal to 5,280 feet. So I put feet on the top, because that's what I want, and miles on the bottom, because that's what I have. What I really want is these miles to cancel. So if they're going to cancel, they have to be one up top and one down low. All right. Then I'm going to convert feet to inches. So I do another fraction with another conversion factor. I put feet on the bottom, so the feet will cancel, and I'm get left with inches. So it's 1, and then I just multiply. 1 times 5,280 times 12, and the bottom is just 1, and I get left with 63,360 inches. This doesn't come up a lot in the exam, but I just want to make sure we kind of cover it here. So I want to take 3 feet per second, and I want to turn it into yards per minute. Okay. So what we're going to do is we're going to convert feet into yards, which is pretty simple, and seconds into minutes. Okay. So we're going to take 3 feet, and it's per, so it's over 1 second. And I want to convert this into yards per minute. So let's do feet into yards first. So I need a conversion factor, something that equals 1 that uses yards. Now I have feet, so feet is going to go on the bottom, and I want yards, so yards is on the top. Okay? So how many yards and how many feet? Well, 1 yard makes 3 feet. All right? So that's my conversion factor, and this fraction is equal to 1. Okay? Now I'm going to do the same thing, except I'm going to do seconds and minutes. So I'm going to do another times. Now I want seconds to cancel, so seconds are up top, and minutes are going to be down low, so the seconds are going to cancel. And there's 60 seconds in 1 minute. And so now I'm just going to essentially multiply across. 3 times 1 times 60 is 180. And then on the bottom, 1 times 3 is 3, which is equal to 60. And then if you look at the feet cancel, the seconds cancel, and I'm left with yards per minute. And so my answer is 60 yards a minute. Okay, we're going to do 2 meters per second into meters per hour. So meters is just going to stay the same, right? This doesn't change. So there's no conversion at the top. What I have to do is convert from seconds into minutes, and then minutes into hours. So 2 meters per 1 second. Okay, and I need to convert seconds into minutes. So seconds are going to go opposite spots in minutes, and there's 60 seconds in 1 minute. And now I want to do another conversion into minutes and hours. So minutes are going to go up top, so the minutes cancel, and there's 60 minutes in 1 hour, and then I'm just going to multiply. So 2 times 60 is 120, times another 60 is pretty big, right? I believe it's 7,200, because it's 3,600 for 60 times 60, and then we just double it. And there you go. And then once again, the seconds cancel, right? The minutes cancel, and I'm left with meters per hour. All right, there's just a couple questions on conversions. There's not much, so we'll get to them as we go along here. And then finding the slope of 2 points. So finding the slope of 2 points, we're just going to do rise over run. So y2 minus y1, that's the change in y, over x2 minus x1 and change in x. There's 2 special cases. Remember that if I have a horizontal line has a slope of 0, and a vertical line has one that is undefined. Okay, so if I look at my 2 points, one thing you can do is label. So x2, sorry, this is x1 and y1 for the first point, and then x2 and y2 for the second point. So when I go to plug in, I'm going to look y2, I'm going to look at the second point, and I'm going to put that first. Okay, see how that works? Minus, and I go to the first point, and I'm going to grab that y coordinate. The first point is right here. Y coordinate is -3. So I do minus, and then I plug in -3 there. All right. We're going to do one question on this real quick. The table below shows the number year and number of households in a building that had high-speed broadband internet. For which interval of time was the rate of change the smallest? So if we can consider these as separate points, okay, let's look at the first change right here. So if we do number 1, all right, and we think about that this is a change, these are all going up by 1 year. So you think about this is a change of 5, right? So if we did number of households over year, you can kind of do the slope in that regard. So if we did the slope here, you would see this is a change of 1 and this is a change of 5, okay? From 16 to 23 is 7, and this is a change of 1. This is a change of 10, this is still 1, right? This from here to here is going to be 9, this is still just 1, and this is 5, and this is 1. So which interval was the rate of change the smallest, right, would be which of these had the smallest increase. So it's either 2002 to 2004. Now I got to be careful here. So see how we counted by 1 every year? This first interval has 2. So look at 2002 to 2004. So that's actually going from here to here, right? This is an increase of 12, but it's actually over 2 years. So you can think about it in terms of the change in y, right? Now what's the independent and what's dependent? If I do the year, does that affect a household, or a household affect the year? So if you want to consider that to be what's x and y here, okay, we can kind of think about this as this is 12 households, but it's 2 years, so this is actually a rate of 6 households per year, okay? The second one you can see is 2003 to 2005, so it's going from 16 to 33, so that's actually a change of 17. And once again, this is over 2 years. So 17 divided by 2, right, is going to be 8.5. So you can see that that rate is a little bit larger, okay? If we look at 2004 to 2006, okay, from 23 to 42 is 19, and once again, that's over 2 years. So 19 over 2, okay, and there's 9.5. And then the last one, you guys get the idea here, right? 2005 to 2007, okay? This is a change of 14. Once again, that's over 2 years. So 14 divided by 2 is actually 7. And so the smallest change would be over the first 2 interval here, the first 2 years, because the rate of change is essentially 6 households per year. All right? So the first thing is X and Y in our chart. So flip that, right? Yeah, that the year is actually independent and the household is dependent on the year. So that's kind of how we're viewing this, is which is the interval. So just in a question you're doing here, just be careful of what we're talking about, and that you're actually looking at the interval and seeing, is it 1 year, is it 2 years, what's the actual change in X, because you need that to calculate the rate of change for that interval of time. All right, that's about it for today, guys. Thanks for sticking with me here.